Okay, here we're asked to calculate the freezing point of the solution. So the first thing we should do is identify what the solute and the solvent is. The solute is the CCl4 and the solvent is benzene. And if we're calculating the freezing point, we need to remember the change in temperature for freezing is equal to the Kf times molality times this I value we're going to say is the number of particles it dissociates into if it does. And so we don't know what the change in freezing point is. For the K value, it depends on the solvent. So we need to go to our table and find benzene. The Kf value for benzene is 5.12 degrees Celsius per molal. And they give us the molality, they don't give us the molality, so we have to go off to the side and figure out what the molality of the CCl4 solution is. So we need to take the 12 grams of CCl4 and figure out how many moles that is, because this is the solute. The molar mass of CCl4 is 154. And so we have 0.0779 moles of CCl4, that's the solute. And then we need to take the 750 grams, which is the solvent, and we need to change that to kilograms, because molality is moles of solute per kilogram of solvent. And there's 1,000 grams in 1 kilogram. So we have 0.75 kilograms of solvent, or in this case benzene. So to get the molality, we're taking the moles and dividing it by the kilograms, and we end up with 0.139 as the molality. 0.139 as the molality. So we can go back up here and put this in. 0.139 is the molality of the solution. And this I value depends on the solute. Okay, if the solute is covalent, our I value is going to be 1. Get out of here. Please, get out. And if it's ionic, the solute, the I value will be greater than 1. Depends on how many particles it breaks up. So we look at CCl4 and we say carbon's a nonmetal, chlorine's a nonmetal, so it must be covalent. So it's not going to dissociate or multiply in pieces when it dissolves. And so it won't affect it, so we can put 1 for that. So our change in temperature for freezing is 0.712. Okay, we're still not done yet because it asks for the freezing point of the solution. So we also can go to the table and find the normal freezing point of benzene. The normal freezing point of benzene is 5.5 degrees Celsius. And we need to remember that this colligative property is freezing point depression. That our freezing point, the normal freezing point of pure benzene is going to be lowered by this much. This is the change in freezing point. So we then need to take 5.5 and subtract 0.712. And because we are left with only a tenths place with the 5.5 originally, we have to round to the tenths place when we subtract. And so we get a final temperature here. This should be our freezing point of this solution, 4.8 degrees Celsius. Okay? Alright, we're going to continue and go down to a boiling point 1. This is actually pretty straightforward. It asks what's the boiling point of a 2.3 molal solution of iodine and acetone. Same type of equation, change in temperature for boiling equals Kb times the molality of the solution times the I value. So again, we don't know what the change in temperature for boiling is. Again, we have to look up on the table. It says, what is the boiling point of a 2.3 molal solution of iodine in acetone? And so iodine must be our solute, and acetone must be our solvent. So acetone wasn't in your textbook, but it wasn't on your worksheet, and it has a Kb value of 1.71